Welcome to our math video clip on the introduction to powers. This is going to be a very general refresher of the understanding of what a power represents. At several times I'm going to ask you to pause the video and to work ahead. Once you've worked ahead through the section, then unpause and check your answers. As I go through, fill in your worksheet as if you're writing a note in class, and then I will be taking a peek at it tomorrow to make sure that it's all completely filled in. All right, so it's important to realize that with powers, somebody along the line way back in mathematical history decided, you know what, I don't want to have to write this out over and over and over again. When I have the very same number multiplied by itself a whole bunch of times, then I'm going to make up this symbol. And when I write a big value, that's the number that's going to get multiplied a bunch of times. And when I write a smaller value up high, let's call it an exponent, that is the number of times you're going to repeatedly multiply this very same value by itself. Together, we call this a power. So when somebody talks about a power, they're talking about the whole thing. And the two parts of the power are the base and the exponent. The exponent in the power tells you how many times to write the base as a product. Now, the product is a multiplication question. A couple of examples: 5 to the exponent 3, 5 multiplied by itself 3 times. 7 squared to the exponent 2. We also have a short form nickname for this as cubed. 5 cubed, 7 squared, multiplied 2 times. So in this first exercise, very simply, it asks us to recognize the two parts of the power. This large 2 with a 3 on it, my base is 2. That is the value that's going to get repeatedly multiplied the number of times by my exponent. So at this point in time, pause your video and work through the next two very quickly. Hopefully we didn't have any trouble with that, recognizing the base and the exponent in each of our powers. When we have a 9 to the exponent 2 or a 9 squared, it asks us to write each power as a product. So that's math speak as write it out and show me exactly what is getting multiplied. So a 9 squared is a 9 times 9. 7 cubed is a 7 times a 7 times a 7. Now, the one thing in mathematics, there are multiple ways of showing multiplication. If you, as you go further into mathematics, you'll have the situation where we use the letter x to represent a variable quite often. And all a variable is a spot in math that I don't know what number I want to put in there right now, so I'm going to put a letter to hold its place. And so I would actually prefer that we move away from using the x crisscross as a multiplication. We're going to talk further about lots of ways to show multiplying, but certainly if I sit two numbers beside themselves with brackets, that indicates multiplying. Another symbol for multiplication in senior math is a dot, but halfway up the line. And so be very careful that you don't mix this up with a decimal. A decimal needs to be down, and a dot halfway up the line means multiplication. So any of those manners. 8 to the exponent 4, we have a nickname for squared and cubed. We don't have a nickname for to the exponent 4. We would just say 8 to the exponent 4 or 8 to the power of 4, and we would have 4 eighths multiplying by themselves in a product. Number 3, write each product as a power. So pause your video now, and what I'd like you to do is to write each of those powers, and then start the video to check your answers. Okay, so we have, oh my goodness, we have 3 3s, 3 to the exponent 3. I think I was looking ahead at the 4s. I have 4 multiplied by itself 4 times. I have 9 squared. I have 8 to the exponent 4. All right, the next exercise has us filling in the missing number. 2 to what exponent would evaluate to a 16. If you're ever asked to evaluate a question rather than simplify, this would be simplified exponential form here, simplified as a product. This would be evaluated. Get it to the final value that it is equal to. How many times do I need to multiply a 2 by itself to get me a 16? Well, a 2 times 2 is 4, times another 2 is 8, times another 2 is 16, so I would need a 2 to the exponent 4. Again, taking a peek, let's skip this one. This one asks me to find the mystery base. What number multiplied by itself 4 times gets me this 81? And for now, we're going to be using simple whole numbers, and so you don't have to worry about decimals or fractions in here. So pause our video. Oh, we'll do this one together. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So 3 multiplied by itself 4 times gets me to my 81. At this point, again, pause your video and find your missing boxes for this number 4 section. Okay, reviewing yours, we just did this 3 to the exponent 4 is an 81. A 3 cubed, 3 3's multiplying together is my 27. A 2 to the exponent 5, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so we get to our 32. With 3 2's, we would have an evaluated 8. 4 squared, 4 times 4 is 16. 5 cubed, 5 times 5 times 5 is my 125. Finally, and probably most importantly moving forward, I want to make a distinction that we can have a base that is a negative number. We can have a base that's a decimal as well, and at this point in time we're not working with decimal bases. We'll just be working with our integers. Integers are the positive and negative whole numbers as well as 0. And it really matters when we have our brackets with an integer base that is a decimal base, or sorry, a negative base. When I have my 4 cubed, a 4 times a 4 times a 4, I can show that as 4 cubed, or I could show it with 4 with the brackets cubed, take a 4, multiply it by itself 3 times. When I have a negative base cubed, with this negative base cubed, it's very important to have the brackets because it does not evaluate to the very same number without the brackets. When I have an exponent on the outside of the bracket, that means take whatever in that bracket and multiply it by itself 3 times. So a 4 times 4 is a 16. Negative times negative is positive. Times another negative. 3 negatives make it overall negative. And 4 times 4 times 4, 16 times another 4 is negative 64. When I write the power in this manner, whatever the exponent is touching directly is what is being exponentiated. And so this could alternately be shown with an invisible negative 1 out front. I have a negative 1 multiplied by this 4 cubed. It does not mean that my negative is multiplied 3 times. I have my negative 1 multiplied by a 4 3 times. Excuse me. Only one negative in that entire mess. And so we get a negative 64 out of that deal. Now it came to the very same evaluated answer, but for a very different reason. What makes a big difference, let's change it to a negative 2 this time, and let's put it to an even power. If I have a negative 2 to the exponent 4 that has brackets around it, that truly means take everything in the bracket, multiply it by itself 4 times. Negative times a negative is a positive, times another negative is a negative, times another negative is a positive. An even number of negatives, I have an overall positive answer. 2 times 2 is 4, times 2 is 8, times 2 is 16. When I have the alternate situation without a bracket, Again, I've got that invisible -1 multiplied by 4 2's in a product. And so I have 1 negative overall. 2 times 2 times 2 times 2 gives me that 16. But this one I'm below 0, and this one I'm above 0. And so please make the distinction that when you have negative bases, they must have brackets on it. Otherwise, it does not evaluate to the very same answer.